Hello everyone, welcome back to my YouTube channel. As you all know that myself Pratibha sir from Sri Venkateshwara College of Engineering Department of ECE 5th SEM. Today I am here to discuss about digital signal processing. The course code is BEC 502. In that we are going to discuss about the topic called Fourier transform and its applications. Firstly, let us go through the introduction. The Fourier transform is a mathematical model that transforms signals between two different domains such as time and frequency. It has many applications in engineering and physics, including signal processing. Here, there are some things to know about the Fourier transform. Firstly, what is Fourier transform? The generalization of the complex Fourier series is known as the Fourier transform. The term Fourier transform, it can be used in the mathematical function, and it also used in the representation of the frequency domain. The frequency of Fourier transform helps us to extend the Fourier series to the non-periodic functions, which helps us to view any functions in terms of the sum of simple sinusoids. Now, let us see how the Fourier transform will work. The Fourier transform converts the function of time or the space into a function of frequency. Properties of Fourier transform. One property of the Fourier transform is linearity, which states that the sum of the Fourier transforms of two signals is equal to the Fourier transform of the sum of the signals. Application of Fourier transform. A Fourier transform is used in many applications such as spectroscopy. Fourier transform spectroscopy is a technique that uses the Fourier transform to translate interferograms into the frequency domain. Mass spectrometry. The Fourier transform icon, cyclotron resonance mass spectrometry, which uses the Fourier transform to determine the mass of ions. And the another one important application of Fourier transform is sound spectrogram. The Fourier transform, it is used to generate sound spectrograms from for analyzing the sounds. Next, now we are going to study about the conversion of signals from the domain from one domain to another domain, which is called as from the frequency domain to time domain, or from the time domain to frequency domain. Converting signals from time to frequency domain, it can help you to achieve the various goals, which includes identifying the dominant frequencies or harmonics of a signal to indicate its source, nature, or quality, filtering out unwanted noise or interference. It is used to improve the clarity, accuracy, and reliability. Modulating or demodulating a signal for transmission, reception, or encoding, and compressing or decompressing a signal to reduce the size, bandwidth, and complexity. Now, how to convert the signals mathematically? A Fourier transform is widely used in mathematical tool for converting signals from time to frequency domains. It decomposes a signal into sum of sinusoidal functions with different frequencies, amplitudes, and phases. This transform can be applied to both continuous and discrete signals, and it has various forms such as the continuous Fourier transform, nothing but a CFT, discrete Fourier transform DFT, and fast Fourier transform FFT. To use the Fourier transform, one must understood the formula and the properties such as linearity, symmetry, convolution, and scaling. Additionally, the appropriate sampling rate, window function, and frequency resolution must be chosen for the signal. Now, let us see the properties of Fourier transform. The first property is linearity. A discrete time signal is said to be linear if it satisfies the principle of superposition and the principle of homogeneity. Second property is memory. A discrete time system is said to be memory system if the output y of n at every value of n depends upon the previous and future values of the input. Note, if x of n is present input, then x of n minus 1 and x of n minus 2 are the previous inputs, and x of n plus 1, x of n plus 2 are the future inputs. If the output depends upon the future or previous input, then those systems are called memory-less systems. If the output depends upon the present input, then those systems are called memory systems. The third property of Fourier transform is time invariant. A system is said to be time invariant if time shift in the input signal causes the same time shift in the output signal. The fourth property is causality. A discrete time signal is said to be causal if output depends upon the present or previous input but not on the future inputs. The final property of Fourier transform is stability. A discrete time signal is said to be stable if the bounded input produces the bounded output. Now, let us see the applications of Fourier transform. The applications of Fourier transform may include signal processing. The Fourier transform is a fundamental tool in signal processing and it is used in audio processing, image analysis, and data compression. For example, in audio processing, it can help to identify the frequencies in a signal which can be used for speech recognition, music classification, and also in noise reduction. The second application is image processing. The Fourier transform can be used to extract the texture and pattern information from images, which is useful for image recognition, object detection, and image compression. The third application of Fourier transform is control systems. Control engineers use the Fourier transform to analyze and design the control systems. The fourth application of Fourier transform is electrical engineering. The Fourier transform is used to analyze voltage and current waveforms in the electrical power systems. And structural engineering. In structural engineering, the Fourier transform can help to identify the structural weakness in buildings and bridges, and it analyzes how they respond to the vibrations and forces. And the next application is mechanical engineering. In mechanical engineering, they can be used to analyze oscotics and vibrations. And the final application includes material science. The Fourier transform can be used to analyze the properties aerospace engineering, and it includes the Fourier transform and which can be used to reduce the vibrations. And in cell towers, the Fourier transform is used to generate the signals in 4G and 5G cell towers. Thank you.